Okay, for today's warm-up, we're going to find the inverse of each function, graph both functions, and verify the inverse relation on the graph. So we're going to have to find the inverse algebraically. We're going to have to graph both using different colors, and we're going to determine if they are inverses if the graphs have reflected across the line y equals x. So to get started, I'm going to go ahead and start by graphing this function right here, which the y-intercept is -4. We go down 2, right 3 from that point to create our linear equation. So over here, we've got -4, 1, 2, 3, 4, make your dot. And then from there, we're going to go down 2 units and then right 3, down 1, 2, 1, 2, 3. And do the same pattern all the way down until you run out of space. The same thing, the opposite direction, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. And continue that pattern 1, 2, 1, 2, 3 until you run out of space this way. So when I'm doing this graph, you just kind of want to do a quick sketch to the best of your abilities. That way you have what the graph looks like so far. So what we're going to do is find the inverse by switching x and y. So change f of x to y and then switch x and y. So this is going to give me x is equal to -2/3 y minus 4. I'm going to add 4 to both sides, so x plus 4 is equal to -2/3 y. And what you need to do to get rid of your fractions is multiply by its reciprocal. So -3/2 is what you multiply here. It cancels. What you do to one side, you do to the entire other side. So we're going to multiply by a -3/2 and use distributive property. That's going to give me -3/2x minus 4 times 3 is 12/2. That's going to give me 6. And that is equal to y. You rewrite it so that it shows it as an inverse, which would be the inverse function of x is equal to -3/2x minus 6. So I'm going to go ahead and graph that. So we go down to -6, 1, 2, 3, 4, 5, 6. Make that point. We're going to go down 3 units and right 2 units. Down 1, 2, 3 over 1, 2. I can't go anymore, so I'm going to go the opposite direction. 1, 2, 3, back 1, 2. We have a point that we intersect at. 1, 2, 3, back 1, 2. And continue that same pattern until you run out of space. And so we're going to go ahead and just make the graph as best as we can. You could find the intersection of that line if you wanted to find that by doing that in your calculator. And we want to make sure that we have reflected over the line y equals x. And y equals x is the imaginary line that if you reflect over it, you have created an inverse. So it appears that that each point from blue to red, they are equidistant from each other, so that is correct. The second question right here, we're going to do the same thing. We're going to graph the first one. So we have -x squared plus 6. So we start at our y-intercept, which is at 6. So here we go. 1, 2, 3, 4, 5, 6. Make your dot. And then you want to find some good points. You can hit Control-T in your calculator. This graph opens downward, and it's the parent shape. So with the parent shape, it has the same pattern that any square has. It's just been translated and reflected. So here I'm going to go down 1 over 1. From there, the next point would be down 1, 2, 3 over 1. Then down 5, 1, 2, 3, 4, 5 over 1. And then if there's enough room, down 7 over 1. And this would be the positive side of this graph. So I'm going to put a plus right there. With a different color, I'll do it in black. I'll just mirror the same thing. So down 1 over 1, down 1, 2, 3 over 1, down 5 over 1, and then down 7 over 1, and make my graph to the best of my abilities. This would be the negative side. So with the positive and negative side, when you create the inverse, you're going to switch x and y. So this is going to be x is equal to y squared plus 6. You're going to subtract 6 on both sides. And then you're going to divide by a negative. And that's going to give me negative x plus 6 is equal to y squared. You take the square root of both sides. Make sure that you add the plus or minus to it. And that's going to give me my inverse, which is the inverse function of x is equal to plus or minus the square root of negative x plus 6. So with that, I can just take the coordinate points that I found and flip the x and y, and you'll see that your graph will open up that way to get there. So we're going to go ahead and graph it and make sure that we have everything in the correct spot. So the positive side, if I see that I have 0, 1, 2, 3, 4, 5, 6, then I'm going to be at 6, 0. 1, 2, 3, 4, 5, 6. And so I'm going to match those points up. If I'm at 1 and 5, then I'm going to be at 5 and 1. And I'm going to continue matching that pattern up. So go up 1 over 1, up 1 over 1, 2, 3, up 1 over 1, 2, 3, 4, 5, and then up 1 over 7. It's going to match these points up. This would be the positive part of this graph right here. And so the negative part, I'll do it in green. It's just the same thing, just matched over. So I go down 1 over 1, down 1 over 1, 2, 3, down 1 over 1, 2, 3, 4, 5, and then down 1 over 7. Those same points right there. You make the curve to the best of your abilities, and this would be the negative side. So if I wanted to show the positive and negative side of this, I'm going to have to make restrictions to the domain. So if I'm looking at this graph right here, if I wanted to look at the positive side only, you'd be looking at when x is greater than or equal to 0. And then for the green graph, you would be looking at it if x was less than or equal to 0, should you want to make the restrictions on your domain. You know that you've done this right if you make the line y equals x, and where these graphs intersect is where that line should also intersect. And with quadratics, if they overlap each other, it should make a heart. It should show a heart. If they don't ever overlap, then they would look like they have been reflected over the line y equals x. That takes care of your warm-up where you have to find inverses given a function, algebraically and graphically.